Okay, this lesson is on function rules. We're in Glencoe Chapter 8, Lesson 2. We'll start with our definitions. So a sequence is a list of numbers in a specific order. A term is each number in a list. An arithmetic sequence can be found by adding the same number to the previous term. And a geometric sequence is where each term is found by multiplying the previous term by the same number. Basically, when we use an arithmetic sequence, we'll be adding or subtracting, and when we use a geometric sequence, we'll be multiplying or dividing. So this lesson is all about rules. So we will describe relationships to find terms. In this list, we're missing 3 terms. Each term can be found by adding 7 to the previous term. So 7 plus 7 is 14. 14 plus 7 is 21. 21 plus 7 is 28. And so to find the next term, we'll take 28 and we will add 7. Okay, so then once we get 35, we will add 7 to 35. Get 42. And then we will add 7 to 42 and get 49. So the next 3 terms are 35, 42, and 49. Okay, on the next set, we see that each term can be found by multiplying the previous term by 2. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So now 16 times 2 for the 4th term will give us 32. So then we'll multiply by 2 and get 64 for the 5th term. And then 64 times 2 gives us 128. So the next 3 terms are 32, 64, and 128. So now you try it out on your own and pause the video and then restart it once you have done these answers. Okay, I noticed that the pattern here is plus 15. So first I'll start with 45 and I'll add 15. Then I'll take 60 and add 15. And finally 75 and add 15. For the next one, start with 4.5 and it goes down to 4, then it goes down to 3.5, then down to 3. It looks like we're subtracting a half or 0.5, or we'll call that 5/10 each time. So we'll start with 3 minus 0.5 and we get 2.5. 2.5 minus 0.5 is just 2. And then 2 minus 0.5 is 1.5. Okay, when I look at the next one, going from 1 to 3, I can do times 3. 3 times 3 is 9. 9 times 3 is 27. So my pattern is times 3. So I'll start with 27 times 3 and get 81. 81 times 3 gives me 243. And then 243 times 3 gives me 729. Okay, and then finally on my last pattern, let's see, I'm going from 3 to 6, 6 to 12. Looks like I'm multiplying times 2. 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, and so on. So 24 times 2 gives me 48. 48 times 2 will give me a 96. And 96 times 2 is 192. Okay, for the next section, we're going to find a rule. So you look in the table, and we have to figure out how the numbers are increasing. So we're going from 1 to 3, and then 2 to 6, and then 3 to 9. It looks like our rule is times 3. So if we're going to find the value of the 10th term, which we could find the value of any term, but this one wants the 10th, we're going to be multiplying times 10. So that's why I have 3n as my rule, because I'm timesing by 3. So then if I want the 10th term, I'll do 3 times 10, which of course gives me 30. Now if I'm going to use this same table and I want the value of the 15th term instead, same rule, 3n, but this time I'll do 3 times 15, so the value of the 15th term would be 45. So this saves us some time. Instead of having to take a table and list all the way down to 15, I can use the rule to find whatever term the question asks for. So then, let's try this out. Find the value of the 8th term. Okay, so step 1 is we need to find the rule. There's a little typo here. This should not be a 1. This should be an 18. So there, if you look at that, we can see a pattern a little bit more easily. We need to see, how is this 2 going to become a 12? The 3 has to become an 18, the 4 and the 24. It looks like my rule is going to be times by 6. All right, so what I'll do is, if I'm finding the value of the nth term, that's 6 times n. And here I want the 8th term. So I'll do 6 times 8, and then I'll have my answer. So the value of the nth term is 48 in this case. Alright, so here's another table. It still wants the value of the 8th term. So first let's find the pattern so we'll know the rule. See, the 3 is turning to a 7. Well, there's nothing I can multiply 3 by to get 7, so it tells me it's going to be an arithmetic sequence. I'll be adding. So 3, 4, 5, 6, 7. So it looks like plus 4. Let's check it. 4 plus 4 is 8, and 5 plus 4 is 9. So that is the rule. The rule is plus 4. All right, so we'll need n plus 4 for that rule. So now if I want the value of the 8th term, I plug in the number 8 for n. So then 8 plus 4, 8, 9, 10, 11, 12. So the value of the 8th term should be 12. Okay, so here are some more function rules. So we'll start by looking at the table. So here we go from a 1 to a 5, from a 2 to a 7, 3 to 9. Well, at first I thought maybe it was multiplication times 5, but 2 times 5 isn't 7, so it must be an arithmetic. I'm adding here, and 1 plus 4 would give me 5. Well, what about 2 plus 4? 4, 5, 6. So if you'll notice, I can't just go up by any rule. That means there's going to be a 2-step rule. So let's take a look at what our bullets say. Notice the values 5, 7, and 9 increase by 2. So that means the rule will have to include a 2 times x. Alright, so I see that nice neat pattern. Increase by 2 tells me that I'm going to have a 2 times x as part of my rule. If the rule was simply 2 times x, then the number of necklaces in 1 hour would be 2. So that's not how many you get. You get 5. The value of 1 hour is 5, which is 3 more than 2x. So then the rule is 2x plus 3, which is 3 more than 2x. And then it says I need to check my rule. Alright, so let's actually check it with this second number. Alright, so if I have 2x plus 3 as my rule, then when I plug this 2 in, I'll need to get 7. So let's see. 2 times, if x is 2, plus 3. Alright, well 2 times 2 is 4, and 4, 5, 6, 7. Oh, it does check. So then I know I have found the correct rule. So on these questions, you have to check your rule, and then you'll know for yourself whether or not you've answered it correctly. So now we're going to try it out. We're going to write a function rule to find the fee for a book that is 8 weeks overdue. Alright, so I start looking, and 1 times 3 is 3, but 2 times 3 isn't 5. And I can say 1 plus 2 gives me 3, but 2 plus 2 doesn't give me 5. So that means it's going to be a combination. It's a 2-step rule with multiplication and addition. Alright, so let's look here at our outputs and see what our increase is. 3, 5, 7, 9. Okay, so we have an increase by 2, so that means 2x will be part of the rule. Okay, so now if it was just 2x, then if I plugged in this 1, it would give me the 2, but it doesn't. It gives me a 3. And a 3 is 1 more than what I would have gotten, so I think I need to add plus 1. And now let's check our rule and see if it's right. Let's use the second set. You can use any of them, but I'm just using the second one. So if I plug in a 2, I should get a 5 for my final answer. 2 times 2 is 4, plus 1 is 5. Okay, so my rule does check. That is my rule. Let's try one more. Okay, so I look at the table. I go from a 1 to 13, but a 2 times 13 doesn't give me 21. And so it must be a 2-part rule, so we'll have to look at the amount of the increase. So when I'm looking at these increases, I also see that there's not a simple number I can add. 1 plus 12 does give me 13, but 2 plus 12 isn't 21. So this is another 2-part rule. So let's start here and see what our increase is. When I go from 13 to 21, that's an increase of 8. And when I go from 21 to 29, that's an increase of 8. So that tells me that 8x must be 1 part of the rule. And now let's figure out what the rest is. So if it was simply 8x, if I plugged a 1 in here, that would be 8 times 1 is 8. Alright, so now we need to count up from 8 to 13. 8, 9, 10, 11, 12, 13. So that's a difference of 5. So 8x plus 5 should be my rule. So let's check. Alright, let's go ahead and check it with this second row. So if I was to plug in 2 in place of x plus 5, let's see if we get 21. 8 times 2 is 16, 17, 18, 19, 20, and 21. My rule checks.